Okay. Let me try to orient my this talk from the application point of view. And as soon as you come to the application point of view, people are depending only on the software. So now if you try to see here, this is here a screenshot, and this is a screenshot of the outcome of an R software. Right, means I believe that that in the due course of time during this course, you will also learn the R software. So at this moment, I will just give you the basic commands, and I have used the screenshot so that you will feel as if you are doing it on the R console, then how the outcome will look like, right? So you will have both the advantages that you will come to know that what are the different commands that can be used in our software to conduct the regression analysis, and yeah, as well as I will and then but surely means you need more thorough knowledge about the R software before you try to attempt these things. But anyway, in case if you are getting a data and suppose you want to do the regression analysis, then this is a sort of outcome that you will get in the R software. And the expectation of each and everyone is very simple. They want to understand what is the meaning of this outcome of the software. Well, this outcome is in the R software, but if you use any other software, you will get a similar outcome. The only thing is, it may be possible that this block may be here or this block may be here and so on. That is the only difference, but the content of the information will remain more or less the same. Right. So my idea is that what is this outcome and how to read this outcome? You should be able to understand what is written on this screenshot at the end of my second lecture. That is my simple objective, that you should be able to read it properly. And reading this outcome is something like reading a horoscope. You know that sometimes I don't believe much, but I have seen that in the horoscope there are this type of some structures where it is written some Chandra, Brihaspati, etc., etc. And a Pandit can read it, but I cannot read it because Pandit can read it because he knows how to understand and how to interpret it. So similar is the outcome where I would like to make you learn that how to read this type of horoscope and try to understand what the data is trying to inform us. Right. So now let us begin our lecture. And we know that whenever we come to statistics, everybody is interested in only one thing. I want to do a modeling. Means now I say means you can see on Facebook, LinkedIn, etc., etc. So many statistical models have come to forecast and analyze the COVID. Nothing is working because there are reasons. Nothing is going to work. But anyway, means if you ask at this time, everybody wants to be a modeler. Everybody wants to give a model for the process. So whenever we are talking of statistics, these linear models plays a very important role in getting good models. And if you try to see what are these models trying to do, these models are simply trying to inform us the process or the amount of information which is contained inside the data structure or the data range or the data which is available to us in the best possible way. Right. If it is not possible to get the information of the entire process in a single shot, then they will try to define it into parts. Right. Means, for example, now you can see during COVID now there are many conclusions. Okay, if you take Kahara, then this will happen, but this will not happen. But for this thing, you need to do this thing, etc., etc., etc. So what are those? That they are trying to get the information in different pieces, and then they are trying to join together so that reasonable conclusions can be reached. So let me try to take a very simple example to give you an idea that what is the regression analysis and where and how are we going to use it. So I have just framed an artificial example, and this example relates to all of us. Means as a teacher, I was always interested as a student that how many marks I'm going to get and how I can control and modify my mark. Similarly, all those research scholars, students, etc., they are always more interested in knowing that how the marks are obtained in the examination. For example, it means many times people come to us and they ask us, okay, sir, that how many hours should I study so that I can achieve at least 90% marks, or how many assignments do you think are sufficient to submit so that I can get at least a grade B in this course, etc., etc. Right. So we know that whenever we are talking of the marks of the examination, then they depends on several factors. Right. One of them. So I have just chosen a couple of factors which are more representative. For example, the number of hours a week of study. That how many hours in every week a student studies. How many assignments have been submitted every month, and how many uh, uh, hours the student has played in a week. And suppose we want to find out a relationship between them. That means we want to find out the relation between the marks of the students and this three variables, which are number of hours per week, number of assignments submitted in a week, and number of hours of play in a week. And then we want to see that how these three factors are going to affect the marks. So for that means I need to develop a mathematical relationship between the two. So suppose I conduct an experiment and suppose I take care to 20 students, right? So well, you can ask me why 20, because in my this slide there is a space only for 20 observation, which I can see and show you clearly. Means if I take 100 observation, the slide will become very clumsy. And my objective here is to explain you clearly. So what I try to do, I try to take here three variables, say x1, x2, and here x3, and I try to take x1 as number of hours of per week study, x2 the number of assignment, and x3 the number of hours of play. And suppose I, Abhay, can you just take care of this thing? Many people are entering into, so you can allow them. Otherwise, that is obstructing my screen. So, for example, Ashish Kumar Shukla entered the waiting room, so you need to admit it. So, can you please do it?
Yes, sir.
Means you can see somebody is waiting in the waiting room, so you allow him, please. Otherwise, that is obstructing my screen.
So he can access your screen, sir, and if they have any queries.
Yeah, because that is blinking on my screen also.
Yes, sir. Yes, sir.
So otherwise, what you can do, you can simply remove this option, because anyway, whosoever wants to come, they can come. Whosoever wants to leave, they can leave. Right. Anyway, I have done it, but you please take care. Otherwise, okay, yeah, my concentration gets disturbed. Right. Okay. So, means I do that. I try to take the first student and I ask that how many means number of how many hours you studied, how many assignments you have submitted, and then how many hours you have played. So this type of information I collect, and can I find that how many marks the student has got, right? So so I can say, for example, number 4 here, that student has got 139 marks, and the student uh, has studied for 33 hours in a week, and number of assignments what he has submitted, this is only 1, and number of hours in a week what he has played is 10, and so on. So these are so that is only an artificial example that I have created. So I try to collect this data, and my objective is that I want to find out a relationship between the y and x1, x2, x3, right? And the form of the relationship is here f, that is known to us. Right. So now the question is this: how to find out this f? And this f can be linear as well as this can also be non-linear also. So the question here is this: now how to proceed further? So now I have here two options. Look at, I can assume that the form of the function is linear or the form of the function is non-linear. So obviously, when we are trying to do any modeling, we know that we have to use some mathematical tools. So surely when we all have experienced that when we want to use the mathematical tools, then it is easier to use the mathematical tools on the linear function in comparison to the non-linear function. For example, differentiating a linear function is easier. Integration of a linear function is easier than the some complicated non-linear function, right? So we assume here that the form of the relationship is linear. Means you can also assume it to be non-linear, and based on that we have linear models as well as non-linear models. And so now our objective is very simple. We want to find out the relationship between the dependent and independent variable in a way which describes the phenomena or the process in the best possible way, right? And this is actually, and this will be called here as your here model, right? So now the question comes here: what is here the model? So yeah, model can be anything. You know that and those Bollywood models, they are very popular. Similarly, you can also say that the relationship between father and son, teacher and student, that is also a model. For example, means everybody wants to use the fair and lovely because Shah Rukh Khan says that if you use it, you will become fair and lovely, right? So why? Because people assume that okay, if Shah Rukh Khan is saying that this is going to be is our model. So what do we really mean by model? That means I also want to look like a Shah Rukh Khan. So that is why I will try to do each and everything so that I may look like a Shah Rukh Khan. But if you ask, Shah Rukh Khan has not followed anyone. Shah Rukh Khan is a Shah Rukh Khan if you consider him as your model. Similarly, it means many of us say that, okay, I want to follow my father and I want to be like my teacher or something like this. So what does this mean? That means either it is Shah Rukh Khan or your father or your teacher. There are always some hidden characteristics which you like and you want to follow them and you want to be like them. So that means you are simply trying to imitate them, and that is how you come to a process where you want to find out the relationship so that you can signify this model. And whenever you are trying to talk about the model, that means all the salient feature of the process they are incorporated into it, right? So, for example, if I say that means if I say my teacher used to teach in the best possible way, so that means I will try to copy them, and I will try to copy them in such a way that whenever I'm trying to teach, I should also teach just like him. Right. So that is the basic idea about the model. And one thing when you are trying to do the modeling, you have to keep in mind that as a statistician, you cannot change the process. You cannot alter the process. Whatever is happening, that will keep on happening. For example, if people are trying to do the modeling on the COVID, the way this coronavirus want to propagate, the virus is propagating, that is only we people, we are trying to understand the trajectory of the coronavirus. And secondly, the statistician has to work only on the basis of a small sample, right? So what is a sample? Sample is a small fraction of the population, and we believe that that sample has all salient features, whatever are present in the population. So that is our basic assumption. Now, in order to explain you what is the regression analysis, so let me try to take here a very simple example. Now, tell me one thing. Now, at this moment, everywhere people are trying to create a model for the corona. So now, tell me one thing. There is a process by which this corona is propagating. There is an approach by which it is multiplying, it is mutating. So now tell me one thing. I give you here two options that there is a process with which Corona is working. And this process is generating the data. That data which we are trying to collect means every day we try to see, okay, these many people have become infected. These are the different factors which are responsible for the spread and so on. And what we really want to do, we want to find out the relationship between this process and the data, right? And I want this relationship to be in the mathematical format. So whatever mathematical relationship I am going to find, that is going to be our model. But now my problem is that we don't know this mathematical relationship. And other issue is even we don't know this process. So what are we going to do? The way if you try to see, people are trying to do the Corona modeling, that they are simply trying to collect the data. And then they are trying to find out the way this Corona is propagating. And using this data, they are trying to establish a mathematical relationship with the process. So if you try to see in real life what is happening, the process is generating the data. But data is not generating the process. But our problem is this, we don't know the process, so we cannot follow this thing. So what we try to do, we try to move in the opposite direction. We try to observe the data, and based on that data, we try to find out the mathematical relationship among these variables, which are trying to indicate the process. So if you try to see, we are moving in the reverse direction. We are moving in the opposite direction. This is something like by looking at the marks, people try to judge that how is the student, how is the teacher, right? If the students are getting good marks, we always say that the teacher taught well and students were also good, right? So now when you are trying to move in the reverse direction, the literal meaning of the regression analysis, the dictionary meaning of the regression analysis is regress means to move in the backward direction. So when we are trying to observe the data and then we are trying to move in the backward direction to obtain the model, that is why this process is called as regression analysis. Right. So whenever we try to determine such a relationship, the first question comes, what should be the tool? How are we going to do it? And then this process is called as regression analysis process. So now let us try to understand that how we can develop the regression analysis for the linear model. So we simply assume that there is a process in which there is an outcome, and this outcome depends on this couple of this independent variables. So what I try to do here, that I try to indicate this outcome by a random variable here y, and which depends on say k independent variable or say k explanatory variable which are indicated by x1, x2, xk. Yeah, for example, this rainfall, the outcome of an agriculture that depends on upon couple of variables like quantity of fertilizer, rainfall, temperature, etc., etc. So definitely there is going to be a relationship between the input and output variables. So suppose this relationship is given by this thing. Y is equal to f of x1, x2, xk, beta 1, beta 2, beta k plus epsilon. So now what is this thing? Do you remember that in your class 10 or class 12, we used to do this equation in the coordinate geometry? Y is equal to mx plus c. So this equation represent the line. So where y and x, they are the variables, and m and c, they are the parameters, because if you know the value of m and c, then you know the entire information about the this line. Right. So similarly, so I can write down this equation here as a, say here y is equal to function of here m, x, and here c. Right. And yeah, there is going to be some random error because whenever you are trying to observe the data, there is a very good possibility that the data is not correctly observable because of several reasons. Right. So, for example, if you ask me the temperature of the temperature of the room, if you say that is 22 degrees or say 30 degrees, do you think that the temperature at every place in the room is exactly 30 degrees? Somewhere it is 29 degrees, somewhere it is 28 degree, and so on. But you just cannot observe it. Similarly, if I ask you that how much is the content of nitrogen in the soil, if you try to take the sample from the different parts of the field, you will get different values of the nitrogen. So this value is not really going to be constant. So, and then suppose if I ask you a most simple question, what do you like, coffee or tea? So, means if you give me an answer, say tea or say coffee, then my trouble is that how to record it in a quantitative way. You will try to use some indicator variable that x takes value 1 for tea and 0 for coffee and so on. But those are only the indicator variable. You are simply trying to approximate the information. Right. Okay. So whenever you are trying to observe such variable, there are going to be many factors because of which you are unable to get the correct observation. And in order to take care of the difference between the true and observed values of the variables, we try to introduce here a random error component, this epsilon. Right. So what we try to see here in this model that this beta 1, beta 2, beta k, they are the parameters which are associated with this x1, x2, xk. Right. So, and they are also called as regression coefficients because they are the these are the values which are really going to give us a good information about the statistical modeling. Right. And then we have this relationship y is equal to f of the function of independent variable and the parameters and plus random error component. Right. So now I have explained you that what are the different meanings of these different components in this here model. So surely if you try to take your epsilon to be zero, that means you are assuming that there is no randomness in the model, then this model will become as a mathematical model. So because in statistics, whenever we are trying to deal with a model, we always try to take care of the random error component. So, and when there is no randomness, then when the mathematics comes into picture, and we get here a mathematical model, right? And so this model is, I think, Abhay, can you take care of this admitting the students because they are blinking again on my screen, so it is disturbing the concentration. Okay, because now this Ashish Shukla entered the waiting room, so you need to admit him. Yeah, right. So now we come to the, because f is in general a function, and in case if we want to consider the linear model. So remember one thing, this is a big actually confusion among many people when we are talking about of the linearity or the non-linearity of the model. The linearity or the non-linearity of the model depends on the parameters. It is not dependent on the independent variable. So a model or a relationship is termed as linear if it is linear in parameters. And if not, then it is called as non-linear relationship. So now if you try to see here, when you are trying to say that the relationship is linear with respect to the parameter, that means the way parameters are entering into your model, their powers has to be only one, right? So definitely when you are talking about the regression modeling, then the model can be either linear or it can be non-linear. And when we are trying to do the regression analysis to find out the linear model, this is called as linear regression model. And when you are trying to do it for non-linear model, then the regression model is called as non-linear regression model. So in the case of linear regression models, the model is linear in parameters, and in the non-linear regression model, the 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 model is non-repeated in parameters, right? And remember, the linearity in terms of the variable, this is not a necessity. So even if I try to write down here a model like here y is equal to mx square plus here c, that is also going to be a linear model, but you know this is a sort of parabola. And so if you try to plot it, it's the relationship will come out to be like this. So remember one thing, that in the regression analysis, the shape of the curve is not really going to 100% guarantee that the model which you want to fit here is going to be always linear. Very important point, right? So as I told you, that when we are talking about the regression means to move in the backward correction. So in the sense that we are first trying to collect the data, and based on that, we are trying to find out the statistical relationship. Right. So now I come back to my uh, case analysis, and you can see here that we have considered this example where the marks of a student, that is y, is depending on three independent variable x1, x2, x3. And if you want to make a relationship among these three variables, that can be written as y equal to x1 beta 1 plus x2 beta 2 plus x3 beta 3 plus epsilon. Right. So this relationship can be termed as a multiple linear or a linear model of y with respect to x1, x2, and x3. Right. Okay. So now what we try to do here, that suppose you have some hypothesis, you want to see whether these marks are dependent on these three variables or not. So what you will try to do, you will try to conduct an experiment, right? And you will try to choose the value of your x1, x2, x3, and then you will try to record the value of your y, right? And you will try to collect such data. For example, I already have collected 20 sets of data, but I just want to show you that how are you going to conduct the experiment. So remember one thing, that independent variable is called as independent because the values that are assigned to the independent variable, they depend only on you. You are the one who is going to take a call that student has to study how much student, how many student, how many assignments are submitted, and so on. Right. So now, if you try to see here the relationship between y and x1, x2, x3, that is there, and we are assuming that this is a linear model. But what is this linear model? What are its values and how it will look like? That is completely unknown to us, and that is our objective, that using the regression analysis tool, we would like to find out such values. So what we try to do, that we have collected this data, and then we are going in the backward direction to find out the model. Now, when you try to say this statement that you want to find out the model, that means essentially you want to find out the values of the unknown parameter. That is the same story if you recall that in the equation y equal to mx plus c, if you know only the value of x and y, and you don't know the value of m and c, that will not help. But if you know the value of m and c, say y is equal to 3x plus 2, then you know the entire information about the line. That where it is dissecting on x-axis, y-axis, etc., etc. Right? So similarly, when we are trying to talk about the model, that means we are interested in the estimation of the parameter. That means we want to know the values of the parameter. So in this case, for example, the parameters are beta 1, beta 2, beta k, right? So now we want to find out the values of these parameters on the basis of uh, the statistical laws, right? So whenever you are actually, you see here, I would try to first address that many times I have seen that whenever people are trying to do this experiment or analysis, they just take the data, put it in the software, and just click, 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 and whatever they get, they assume that now they have become the god and they have got the best possible model. This is not actually correct. So whenever you want to do the regression analysis, that means you want to analyze some problem. So first of all, you have to state your problem very clearly. Don't expect that after you collect the data, wrong data, and you come to us and then try to ask us that you want to analyze this thing. There is a good possibility that you want to know the height of the father, but you have collected the data on the age of the son, right? So the statement of the problem could be very clearly specified that what we really want to know, and then how this process is going to affect that outcome. For example, if you are studying the marks, then marks are going to be dependent on number of students they are studying, they are submitting the assignments. Similarly, if you are trying to think about is agricultural, then the crop is going to depend on many other factors, the temperature, fertilizer, etc., etc. So you have to choose the relevant variable, and then you have to collect the data on those variable. You have to assume the form of the model, and then you have to choose a statistical method that how are you going to fit the data. That means how are you going to estimate the parameters, and then you have to execute it. And after that, it may be possible that the model you are going to get that is not really close to the true value. So means you have to actually see that whether this fitted model is good or bad. So what we try to do, suppose if I have suppose 100 observation. So for example, means I'm giving you one possible option that I will try to use 80% of the observation in the modeling of the data, and then I will use the values of the 20% remaining observation to see what my model is going to give us as an outcome. And then I try to compare the outcome which my model is giving and which in real life I'm going to get. So this is called as model validation, and we try to criticize the model in the sense that we want to show that, okay, we want to make sure that my model is giving us the good outcome. And then means you have to see that whether the a given model is giving you the correct solution or not. So now, whenever we are trying to consider a process, that process can depend upon only one independent variable, or that can depend upon more than one independent variable also. So when the process is depending only on one independent variable, then the model that we try to obtain with one dependent and one independent variable, this is called as simple linear regression model. And when we have more than one variables, then we call it as a multiple linear regression model. So in this lecture, we are going to talk only about the simple linear regression model, and in the next lecture, I will try to talk about the multiple linear regression model. Right. So now, so we consider here the same example, and now what I try to do here, that instead of taking here three variables, that we try to choose here only one variable, that the number of hours of per week of study, and their maximum marks. So now, just like there is here now here one independent variable here x and one dependent variable y. So the relationship between them can be expressed as a just like y equal to mx plus c. So I can write down here as a beta 0 plus beta 1 x. Why? Because in statistics there's an understanding that whenever we are trying to write down the parameters of the model, they are usually written in the Greek letters, and when we are trying to write down the variables, they are written usually in the Latin alphabets, that is ABCD, etc. Right. So that is why if you try to compare it with your y equal to mx plus c, so beta 1 is something like here m, beta 0 is something like here c, and epsilon is the random error component. So this beta 0 and beta 1, they are called as regression coefficients in general. And in particular, beta 0 is the intercept term, and beta 1 is the slope parameter. And epsilon here is the random error component. And remember, this random error is not observable. And yeah, and it takes care of all the factors which we are unable to handle, and because of which there is a difference between the true and observed values of the variable, right? So yeah, I mean, I already have explained you that how this comes into picture. So now if you want to fit here the model, so now you have assumed the form of the model to be here y equal to beta 0 plus beta 1 x plus epsilon. So now if you want to get this model, that means you want to know the values of beta 0 and beta 1 at this moment. So we need to collect that data on x and y. So we try to conduct an experiment and we try to collect, say, n sets of information on the paired observations of x and y. So I will try to give here the value of x, but then I will try to note down the value of y. Similarly, I try to change the value of x, then I try to get the another the value of here y. So similarly, you will have here. Suppose you try to conduct this experiment n times, right? So you will have here n sets of paired observations.